Hi ladies and gentlemen, this is Mr. Green and this is another in my geometry lessons. We've been talking about trigonometry. And in trigonometry, one of the things we're going to talk about is, there are just some angles that occur all the time. And do I really have to do all this work for trigonometry to work that out? We'll talk about that today, okay? So, what are we looking at? We're looking at the third sets of lessons in trigonometry. It's called special right triangles. So, don't forget, look for quiz corrections that you need to be making, get them taken care of. Due dates, let's not let any zeros be hanging around out there. Let's get them taken care of. We want to get all the zeros out of the grade book before we go too far. So let's look at these special right triangles. The first one we're going to look at is the 45, 45, 90 triangle. You know, there's just some things we know about the 45, 45, 90 triangle. It's an isosceles triangle because the angles are equal, right? If two base angles are equal, I'm sorry, I got a cough. So stop the recording and then cough and then come back to it. So if I got two triangles a triangle that has two base angles that are equal, then the sides are equal. Well, that's true in a right triangle. True in a isosceles triangle like this. And since it's 45, 45, 90, these two sides are going to be the same. Two angles are the same. Two sides are going to be the same. Now, if I use the Pythagorean theorem and worked out the distance on this other side, it's going to be the square root of 2 times that other side, a. That just is how that value works out to be, square root of 2a. And so it's real easy to find that using the Pythagorean theorem. Now, if I were using trigonometry, I would say, well, the tangent or the sine of a 45-degree angle would be a divided by this one over here. It turns out that that is actually what it turns out to be. It's a divided by the square root of 2. Easy enough to do. We can find these sides that way. But you know what? 45, 45, 90 triangles occur all the time. And since we know they occur all the time, we can just memorize that ratio. The ratio of a 45, 45 triangle to the sides, a, and the square root of 2 times a. That's easy to remember. Why? Because I've got two a's and the square root of 2. That becomes easy enough to memorize. So let's look at that. Here I've got a triangle. I've got a 45, 45, 90 triangle. So if I'm looking at this side over here, it's going to be the same as this one, s, divided by the square root of 2. And so if I take the sine of a 45-degree angle, it's going to be the opposite, which is going to be s divided by s times the square root of 2. Well, the s's are going to cancel out, and I'm going to have 1 over the square root of 2, which mathematicians hate. And so we actually just multiply this by the square root of 2 over the square root of 2. And what we wind up with is the square root of 2 over 2. And that's what we would get for the sine of the 45-degree angle. Square root of 2 over 2. Now you know what? Amazingly, cosine is going to be exactly the same thing. The tangent is going to be s divided by s. That's going to be 1. You know what? That's easy to remember. That just by memorizing these special right triangles, we can memorize some sine and cosine functions. We don't have to go punch them on the calculator or do them on the calculator or find them in a table or something like that. Becomes easy to do. Are there other triangles we can do that with? Yeah, the 30, 60, 90 triangle. Remember that one? We talked about this earlier in the year too. This one, 30, 60, 90. The angle opposite, the side opposite the 30 degrees, that's just the smallest side. The hypotenuse is going to be 2 times that smallest side. And there are 3 different side lengths here, so we're looking at the square root of 3 times that side. That's my ratio of my sides. That's easy enough to remember. If I know that ratio, I can find the sine of a 30-degree angle. It's going to be s divided by 2s. The s's are going to cancel each other out. I'm going to get 1/2. That's going to be my sine of my 30-degree angle. It's 1/2. How about the cosine of a 30-degree angle? Well, the cosine is going to be the adjacent side, which is going to be square root of 3 s divided by s. Well, the s's are going to cancel each other out, and I'm going to have the square root of 3 divided by 1. Oh, wait a second, cosine. 2s down here. 2s, because it's the hypotenuse. Square root of 3 divided by s. The s's still cancel each other out, and I will get the square root of 3 over 2. Now, for my tangent of 30 degrees, it's the opposite divided by the adjacent. So it's going to be s divided by, adjacent divided by opposite, isn't it? Opposite divided by adjacent. Yeah, so you got to make certain you know. S divided by square root of 3 over s. I'm going to have a square root of 3 in the denominator. Not going to like that, so I multiply by square root of 3 over square root of 3. And I wind up square root of 3 over 3. That is my tangent. Do you see how I could work through these just knowing those ratios? How about for a 60-degree angle? That's a slightly different one. My sine is going to be the square root of 3, this opposite side, square root of 3 over s divided by 2s. The s's are going to cancel each other out, and I'll have the square root of 3 over 2. Okay? The cosine, adjacent side divided by 2s, s divided by 2s, that's 1/2. Tangent, same sort of thing. I'm going to take the opposite divided by the adjacent, square root of 3 over s divided by s, and it's going to give me the square root of 3. Okay? So, here's an example problem. What if I had a tree, and then we wanted to find how tall that tree was? Why? I don't know why we wanted to find how tall that tree was, but we want to find how tall that tree is. We can see that there's a 60-degree angle here when we're standing 10 feet away from the tree. So what can I do? I know the ratios, don't I? Well, knowing the ratios, I know that this is 10, this is 20 here. This one is going to be the square root of 2 times 10. And that's what that height of that tree is going to be. Okay? If I wanted to do it with trigonometry, I could say that the tangent of a 60-degree angle is going to be equal to, what is the tangent of a 60-degree angle? We just worked it out. Square root of 3. So that's going to be the square root of 3 times 10. Used the wrong number there. Square root of 3 times 10. And that's what it's going to be. And I paused there for a second because my brain got blown here a little bit. The sine of a 60-degree angle would be x over 10, right? No, it wouldn't be x over 10. That's not x over 10 at all. It's x over 20. I don't know where they got that 10 from. So this would be 20 times the sine of 60. Okay, and the sine of 60 is this. That's 20 there. And so we're going to get 10 times the square root of 3. And so it's going to be a little bit higher than what they're saying. Okay? I looked at their answers here and hadn't seen them before. It kind of caught me off guard. Because the sine of 60 is not the sine of 60. It's square root of 3 over 2, right? That's where they're getting this from. Okay? But we know that this is not x over 10. That's not what the sine is. Because the sine is 20. This side over here would be 20. It'd be twice that length. Okay? Okay. I do appreciate you guys letting me know that you're in geometry and what section of geometry you're in every time. It does help me make certain that I get your information to you quicker. And I look forward to talking to you